side chains. Now take note, class, that all, as what I have said, all amino acids vary only on the R. The rest, they all have the same structure. So bariho tanan except this kaning red, they are R. Okay? So you have alanine now. Please take note also of the abbreviation, the symbol. I think that will come out. Say for alanine, it is abbreviated as ALA. ALA. I prefer this. First three letters. The first three letters, then isoleucine, ILE, leucine, LEU, methionine, MET. Okay? Phenylalanine, PHE, PHE. Proline, Pro. So, I prefer the first three letters for the abbreviation. Valine, Val, tryptophan, TRP. Okay, so we have there. Those are non-polar side chains. When we say side chains, kaning are. These are side chains. The side chains.
Ma'am, tunan pa na mo sa form structure.
Ay, yes, dali raman siya. Dali ra siya kay naa naman kaani. They all have the same structure except they are. Now, usually when I give you, say, request you to construct a specific structure of an amino acid, I choose those amino acids with shorter side chains
So, alanine.
for easy
So, alanine and glycine.
memorizing. They memorize easily. Yeah.
Alanine lang mo, glycine. Okay lang yan. Pwede po balik.
Okay. So, polar side chains are the following. Yeah, asparagine, glutamine, tyrosine, cysteine, serine, threonine. The polar side chains. So, kaning mga polar side chains. So, kaning nga side chain, kay polar man, so, can interact with water. Ang non-polar can interact with mga lipids. Mga non-polar side chains. Okay, acidic and basic side chains. Aspartic, glutamic, arginine, histidine, glycine. Okay. Now, all 20 are alpha amino acids. So that's how we commonly write them. These amino acids in a form of an alpha. Now, for out of the 20, 19, the alpha amino group is primary. You say primary, linear. Linear. For proline, it is secondary. Secondary is helical. Helical. Now, with the exemption of glycine, the alpha carbon of H is a stereocenter. Isoleucine and threon H contain a second stereocenter. So, mga duha ka stereocenter. Okay, ionization. Now, net charge on an amino acid depends on the pH of the solution in which it is dissolved. Now, say for example, class, if we dissolve an amino acid in water, now usually it is in the form of Zweiter ion, as what I have said. When we say Zweiter ion, say amino acid, say alanine. You dissolve nimo with water, ang iyang structure would be in a Zweiter ion. Na ay negative, na ay positive charge. Zweiter ion. There is positive and negative charge. Say, now, if, however, so that is when the solvent is water. Now, take note of this class because you'll be using different solvents in the laboratory, and then you will be asked as to what will be the possible structure of your amino acid. So, given the amino acid, and then given various solvents. What will be the possible outcome or the product, or say the structure, after it is dissolved in different solvents? Now, as what I have said, when amino acid is in in water, it exists as in an aqueous solution, in a Zweiter ion. Now, if we now add a strong acid, like for example, hydrochloric acid. So, you have the amino acid plus hydrochloric acid. Now, like this. So, what will happen? Now, the hydrochloric acid will bring the pH of the solution to 2.0 or lower. So, the more, we say, when the pH goes lower, meaning the molecule becomes more acidic. Say, if the pH, remember the pH? Say, if mo ni ang 7, kani ang 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 9. 8, 9, 10, 11, 12, 13, 14. 8, 9, 10, 11, 12, 13, 14. Say, this is now the reading of the pH meter. The pH meter. If the reading falls below 7, meaning it is acidic. This one is neutral, like water. And then this one is basic. Now, say for example, if we will add hydrochloric to our amino acid, so hydrochloric acid is a strong acid. Now, what is now the behavior of our amino acid? Okay. Now, we have here the RCOOH, or the carboxylic acid, cannot exist with base. Again, this is base. Here. Acetic acid. Here. The amino, or the RNH2, I should say. If we will add hydrochloric acid, now, the amine or the RNH2 cannot exist in the presence of weak acids such as acetic acid. Now, these tend to gain proton to become ammonium ion. So, ang iyang charge sa kayon is RNH3, positive. Thus, the amino acid which has COOH and NH2 groups when in water, so okay, of course, this is becomes Zweiter ion. Now, ang mahitabo, if halimbawa, if we will add the hydrochloric acid to amino group, or say to amino acid, in such a way that the solution would tend to go lower than 2. Now, the strong acid donates. What is this strong acid? It's the hydrochloric acid. It donates the proton to the carboxyl group. Iyang ihatag ang iyang proton. It donates, meaning the hydrochloric acid, say you have the HCl. Now, kani mo na source sa iyang proton. The A's here is donated by the hydrochloric acid to the carboxyl group. Remember, COOH siya. Negative. Ionized siya. So, i-donate ni HCl sa carboxyl group of the amino acid, turning the Zweiter ion into a positive ion. So, mahimo na dayon siyang positive ion. So, you have here, okay. So, let's in water. So, if you have here the amino group, or the amino acid plus the hydrochloric acid, the hydrochloric acid donates its proton, or the H. So, this will become COOH. So mahimo na ni siyang COOH. So ang iyang charge now is becoming positive. This is the overall charge of the amino acid. Are you with me? Mhm. Now that is what happened if we will add hydrochloric acid to our amino acid. So the tendency, the proton of the hydrochloric acid, say for example, will be given the H here. This is now the proton, the source of our proton, will be given or will bind with this carboxyl group to become COOH. And what is left now is, of course, you have now positive. No? So, positive ion. So, positive ang charge sa ato ang amino acid. So, if you are asked what is the charge of our amino acid if a hydrochloric acid is given or say is added, so the charge will become positive 1. So it becomes positive. Okay? Positive ion. Now, if we add a strong base such as sodium hydroxide, now sodium hydroxide or NaOH is a strong base. If you will add to the solution of our amino acid to bring its pH up to 10, so paasa ka na. Diri, this is basic. Para maabot og to become our, remember, ang atong amino acid can be in a Zweiter ion. Pwede siya base, pwede po siya acid. Now, it depends now, its overall charge depends on the solvent that will be added to our solution. Now, if you will add sodium hydroxide to the solution in such a way that the pH would be going up to 10,